Okay, now we have section 12.3, which is measures of dispersion. So in this section, we're just going to learn some different ways to measure data, and you're going to see why it's important to know this compared to the last section, okay? So measures of dispersion are used to describe the spread of a data items in a data set. Two of the most common measures of dispersions, the range and the standard deviation, are discussed in this section. All right, so first let's start with a little bit of a review. So get your calculators ready. We are going to find the mean, median, mode of these two data sets. So we have two, apparently they were bowling, and we have their data set here and here. We want to know the mean, median, and mode for each one. Okay, so remember the mean, you add all the numbers, divide by, in this case we have 5 numbers, so add them and divide by 5. Same thing here, you add them and divide by 5 to find the mean. The median is the number in the middle. It has to be in order from least to greatest, which in this case they are. So you know what, we can do the median right away. Looks like the middle, the median is 165 for both. The mode is the number that appears the most. So on this case, in these two cases, I don't see anything, so there's no mode. There's no number that repeats for either one of these sets, okay? So now if we do the mean, which is the average, you add and divide by 5, we get that this is 168 and this is 168. All right, so in summary, these two data sets, there's a weakness using only the measures of center, which is what we covered on the previous section, because even though these two sets are completely different numbers, they only repeat the 165 in the middle, we get that the mean, median, mode is exactly the same thing. So that doesn't really help us here, okay? So that's why in this section we're going to cover different ways to measure. So for example, we're going to start with the range. So the range is a simple but not rough measure of dispersion. So basically you take the highest value and you subtract the smallest value from that. Okay, so the biggest minus the smallest, basically. Okay, so if we do that here for Keith, we're going to subtract 213 minus 144. So let me write that here. So 213 minus 144. And whatever that is your range. Okay, so in this case, is 69 is your range for Keith. We're going to do the same thing for the other person. So we have the highest value is 187 minus 142. So we do that. We do it a different color. So 187. Type that in the calculator, minus 142. In this case, the answer is a smaller number, which is 45. We can say that this value, because it's smaller, is more consistent. Okay? The closer to 0 the number, the smaller the number, the more consistent it is. Okay? So that is the range. The range is an easy one too. So now you know how to find the mean, the median, the mode, and the range. Okay? Alright. Standard deviation is the measure of how much the data in certain collection are scattered around the mean. Okay, remember the mean is the average. Okay? A low standard deviation means that the data are tightly clustered. A high standard deviation means that they are widely scattered. Okay, there is a formula for the standard deviation, so let me write that in. We say S is equal to the square root of the summation, and you've seen this one before, of x minus x bar, which is the mean, square all over n minus 1. So remember, n is the number of values that you have on your set. So for example, here on this data set, you have 5. N is 5 because you have 5 numbers. Alright, so here is your formula. We are going to practice this right now on the next problem. Okay, so number 3 says find the standard deviation for Keith and Mike's bowling scores. So we're still using the same scores as before. So let's do Keith's first. It says the mean for both bowlers was 168. That's what we got on the first part. Alright, so we're gonna do each of them by parts, I guess. So we can say that. So these are the scores. The deviation is subtracting the score minus the mean, okay? So for example, here we have 144 minus the mean. The mean was 168. That's x bar, which is the mean, okay? Alright, so we're going to do the same thing for this one, 147 minus 168, and that gives you negative 21. Same thing on the next one, 165 minus 168, that gives you negative 3. Next, 171 minus 168, that gives you positive 3. And the last one, 213 minus 168. That gives you 45. Now you add them all together and that's going to give you your total. Okay? Which in this case, this is going to be 0. When you add those two together, it's going to give you negative 45 plus 45. That's going to give you 0. Alright, so now we're going to do the summation part of the difference, square it. So the difference is going to be this. Why? Because we already subtract them and you're going to square it. So I'm going to take each of these answers and I'm going to square them, which in this case is 9. 3 squared is 9 again. And since we are squaring every single number, all these numbers are going to be positives. They always have to be positives. Alright, now remember that this symbol is sigma, is a Greek letter and means summation. So we're going to add all these numbers. So I'm going to add all these numbers. You're going to add them together. So type it in the calculator and make sure you get 3060. Alright, so now we have everything that we need for our standard deviation. Remember, this is a formula for standard deviation. Now there is a way to do this on your scientific calculator. I did post a video on your Canvas. So where you find this video, right below there's a video that tells you how to do this on the scientific calculator, okay? You have to input all the values and press some keys on your calculator. Alright, so now we're going to take the summation, which is this, 3060, divided by n is the number of values that you have on the on the data set. Sorry. So that's 5 minus 1, which equals 4. So we have the square root of 3060 divided by 4. Divide that and take the square root on your calculator. We are going to get a decimal. So it looks like we're going to approximate. We're going to have to round to the second decimal here. So I have 27.66. That's my standard deviation, okay? Now, I'm going to have you guys try this, the next one. So for Mike's, it looks like, or Meeks, whatever his name is, we're going to do exactly the same thing, okay? So we're going to subtract. The mean is still the same. and we're going to try to find the standard deviation for this one as well. So I want you guys to try this one on your own right now as you're watching this. We're going to check our answers in class, and we're going to finish the rest of the section, okay? If you have any questions on how to find the range or how to find standard deviation, I'll be happy to answer those questions in class. All right, thank you for watching this.